Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 47, and this is lecture number 6 of the physical chemistry chapter solid state. The subtopic of this lecture number 6 is structure of KCl or potassium chloride. This is the structure of potassium chloride where it is formed after interpenetration of two face-centered cubic lattice, one made by potassium cations, another made by chloride anions. So this is isomorphous with that of sodium chloride. But the first order spectrum shows that the ratio of the interplanar distances such as D100 is to D110 is to D111, it completely resembles with simple cubic or primitive lattice. That is, this is 1 is to 0.707 is to 0.577. From this, we can conclude that the D100 is to D110 ratio is similar to that of sodium chloride. But if you go to compare the ratio for one D111 plane, in that case you will find that this is just half of that of sodium chloride. So, in case of sodium chloride, it was 1.414 compared to D100, but this one is 0.577 compared to that of D100. Hence, this D111 plane shows the value which resembles with that of the primitive unit cell. Why this is so? The masses of potassium cation and chloride anion are nearly the same. This is the reason. Because in case of sodium chloride, the mass of sodium plus ion was little bit lighter than that of potassium. So, the high intensity lines could not be produced during Bragg diffraction. But since potassium cation is much larger than sodium cations, so it is quite capable of diffracting the X radiation with high intensity lines. That is why this is also taking part in producing the Bragg diffraction reflection maxima. And hence they have the same diffracting power, resulting in a normal XRD pattern of decreasing intensity with increasing order. So now come to the question why simple cubic despite being face-centered cubic. If you divide this unit cell into equal number of 8 small cubes, then you will see this type of structure which comprises 4 K plus ions and 4 Cl minus ions, and within the crystal there is a half KCl molecule. Why half KCl molecule? Because this one contributes 1/8, this one contributes 1/8, so there are 4. So 4 into 1/8 means half K. 4 into 1 plus 8 Cl minus equal to half Cl minus. Therefore it is half KCl. Total there are 8. So 8 into half equals to 4. That means there are 4 number of potassium chloride moieties within one unit cell. Now come to the point, if you divide this into equal number of 8 small cubes, then this small cube behaves like a simple cube, because likewise chloride ions, the potassium cations are also capable of producing high intensity lines after diffraction. That is why the D111 line produced such a spectra. Therefore, the interpenetrating face-centered cubic lattice of potassium chloride behaves like primitive lattice. Now, each unit cell contains 4 potassium chloride molecules as we have discussed it. Each small cube contains half KCl molecule. There are total 8 number of small cubes, so 8 into half equals to 4 KCl molecules. Now let us calculate the coordination numbers. One potassium ion is surrounded by 6 chloride ions and vice versa. That means one chloride ion is also surrounded by 6 potassium ions. So it's a 6:6 structure, the nearest neighbors, and therefore the coordination number of each ion is 6, like this. Look at this animation. This is the structure. Okay, now just take this point as the potassium ion and take only 6 ions which are nearest to it. This one is closer, 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 and finally this one is closer. Okay, So along the edge, this distance is the shortest distance, but here to here it's a diagonal distance. So this is not nearest, it is little bit far, therefore we cannot take into consideration this one. Okay, now if these 4 are the equatorial positions, then these 2, this one and this one are the axial positions. Okay, now let me remove all the remaining lattice points. It looks like this. Okay, so that is why it is 6:6 ion. In case of chloride also, if this is chloride, then these 6 are potassium ions. Now around 1 potassium ion there are in the second nearest neighbor, how many other potassium ions? Or around 1 chloride ion there are how many other chloride ions at the second nearest neighbors? Look at this picture. The number of second nearest neighbor of each ion is 12, and how it is 12, just have a look here. Okay, just remove all the white balls. Okay, only keep the black balls. Then you can see, just have a look here in this picture. Look, I remove all the white balls. Okay, only kept the black balls, and these are all having equal distance. This is along the phase diagonal. Okay, here to here, this is the phase diagonal. Here to here, phase diagonal. So same distance, all the 12th number of potassium plus ions, or if this is chloride, then all the 12 number of chloride ions in the second nearest neighbor, okay, they are equally distant. If this distance is a by 2, half of the edge length, if edge length is a, this is a by 2, then here to here is a by 2 root 2. That means a by root 2 distance. So at a by 2 root 2 distance, there are 12 number of second nearest neighbors. So the number of second nearest neighbors of each ion is 12. It is applicable for both potassium as well as chloride. So that's all about the structure of potassium chloride. Thank you and have a nice day.